Good morning, dear students. In last class, we have discussed regarding the what happens whenever we are applying the external opposite potential on the galvanic cell. At that time, three cases are observed. What are the means? First one is that the external potential is less than 1.1. This is the first case. Second case is external potential is equal to the 1.1, and external potential. Third one, that is external potential is greater than 1.1. Okay, right. Next, first we'll discuss regarding the external. Already I discussed. Whenever the external potential is less than 1.1, at that time what happens? What about the flow of electrons and the current? Okay, and which one is acting as a anode and cathode? Okay, first point, that is here electrons flow from where to where? Electrons flow from zinc to copper and what about the current one? Current flow from copper to zinc. Okay, this is the first point you have to remember here. Electrons flow from zinc to copper and current flows from copper to zinc. Okay, next one. What is the next one means? So here zinc dissolves at zinc rod, and what about the copper? Copper deposited at copper rods. Okay, these are the 2 points you have to remember. Okay, it means whenever the external potential is less than 1.1. Next, one more point that is also very important for us. What is that one means? First point, that is now zinc dissolves at zinc rod. At the time what happens? Now that Zn is converting to the Zn2 plus. Okay, and next one, that copper C2 plus. Okay, by the gain of 2 electrons, now it is converting into the C. It means what I want to say means here loss of electrons here. Loss of electrons means oxidation. Loss of electrons means oxidation, and gain of electrons, Cu2 plus is converting to the Cu. What is the meaning of this one? By the gain of electrons, okay, now that Cu2 plus is converting to the Cu. It means now here we observe the reduction. Now what is the point here you have to remember means now here, okay, always. Okay, whatever it may be the electrochemical cell or the electrolytic cell, whatever it may be. Okay, always oxidation takes place. Where oxidation takes place? Always oxidation takes place at, and this is the point you have to remember. Okay, and always reduction takes place. Always reduction takes place at cathode. Okay, so these are the 2 points you have to remember. Okay, always oxidation takes place where oxidation takes place at anode. Okay, and what about the reduction means? Reduction takes place at cathode. Okay, one shortcut is there. What is that one means? Now coming to the reduction, what is the first letter R, and in cathode what is the first letter C. Now you remember like this, that is CR. CR means if you take one class, already for every class, so we observe the presence of the class representative like that here also. So CR means, so R means reduction and C means cathode. Always reduction occurs at cathode. Okay, now just you remember this shortcut CR, R, RS. Now you just you remember this one. A, O means in anode first letter is A, in oxidation what is the first letter? O. AO. Okay, just you remember this shortcut. So it is better to remember this one CR. Okay, CR means C means cathode, R means reduction. Okay, always reduction takes place where? Always reduction takes place at cathode. Okay, right. So this is regarding, that is whenever the external external potential is less than 1.1. Now, if it is external potential is equal to 1.1 means what is the meaning of this one means at that time we cannot observe either the flow of electrons or the current. It means so whenever the external potential is equal to the 1.1 at that time there is no chemical reaction. Okay, right. Next, coming to the third one. Now, if we consider the third one, that is external potential is greater than 1.1. If the whatever the opposite potential, external opposite potential that is applied on that galvanic cell, if it is greater than 1.1, at that time what happens? Now here. So first one, what are the points we have written there? First one, that is electrons flow. From where to where means electrons flow from copper to zinc. Electrons flow from copper to zinc. And what about the current means? So current flow from, okay, so that is zinc to copper. Zinc to copper. Reverse to the first one. Okay, next one. What is the next point? That is if you take the zinc deposits, okay, that zinc is going to be deposited at zinc rod and copper dissolves at copper rod. Okay, reverse to that of the first one. Okay, now in case if you consider this one, flow of electrons from copper to zinc. Okay, now it is non-spontaneous in nature. Non-spontaneous means nothing but so this reactions not occurring, they are not going to be occurred on its own. If you want to occur such type of reaction at that time, so we have to supply some external energy. Okay, if we supply that external energy, then only we observe the flow of electrons from the copper to zinc. So that's why it is a non-spontaneous one. But coming to the flow of electrons from zinc to copper, that is example for which one? It is the example for the spontaneous reaction. How we can explain that one is based on the SRP values. Okay, we'll discuss later, just to remember. Now, flow of electrons from copper to zinc, it is a non-spontaneous reaction. Best example is if we consider always flow of water, okay, from top to bottom we observe. Okay, so water can easily flow from top to bottom. But if you want to flow that water, means if you supply the water from bottom to top, at that time we cannot observe the flow of water from the bottom to top. At that time compulsory we have to use the external conditions we have to apply. It means at that time if you use the motor, in our houses also we are using the motor. What is the main function of that motor means? Now it is going to lift the water from bottom to the top for the transfer of water from, okay, groundwater or whatever it may be, from sink to the tank. Okay, at that time, so compulsory we have to use the external conditions. That is, if we use the motor, then only water can be transferred from, okay, lower end to the top end, from bottom to the top. Okay, without using any external conditions, we cannot transfer the water from bottom to the top. But we can easily transfer the water from top to bottom. Okay, so top to bottom, flow of water from high end to means top end to a low end, bottom end. So that is the spontaneous in nature. But flow of water or transfer of water from bottom end to the top end, okay, that is non-spontaneous. Okay, for occurring such type of reaction, compulsory we have to use the external conditions. Like that here also, okay, electrons flow from copper to zinc. Of course we are observing it is a non-spontaneous reaction. For occurring such type of non-spontaneous reaction, compulsory we have to supply the energy. Okay, so that's why just once check this one. External potential is greater than 1.1. It means now that opposite potential that is applying now that is greater than 1.1. So it means what is the meaning of that one? Now we are applying the electrical energy. By the usage of that electrical energy only, now here we observe the flow of electron from where to where means from copper to zinc. from copper to zinc. So, and what about the current means? The current flow from zinc to copper. Okay, so that's why they are the non-spontaneous reaction. For occurring such type of non-spontaneous reactions, compulsory we have to apply the external conditions. Now here we are applying the energy. Which type of energy we are applying here means electrical energy we are applying. Sir, how we are telling something? Just see this one. Once you get this third case. Now that external potential is greater than 1.1. So due to that reason only, now by the usage of that electrical energy only means that electrical energy is converting into the chemical energy. Electrical energy now it is converting into chemical energy. Okay, so it means so now already we know. So a cell in which we observe the conversion of electrical energy into chemical energy, that one is known as, that is called as electrolytic cell. That is called as electrolytic cell. Okay, it means now what is the point you have to remember means actually, so whatever the cells we have discussed, they come under the galvanic cells. Okay, in galvanic cells what happens? Already we know, that is Daniel cell, whatever you take. Now in that Daniel cell, okay, chemical energy is converting into the electrical energy. Chemical energy is converting into the chemical energy is converting into the electrical energy here. So if you take the galvanic cell is the best example for the electrochemical cell. It means so here what happens with normal conditions means if external potential is less than 1.1, okay, at that time, so we observe the flow of electrons from zinc to copper. It means so here in case if you consider the first case, now it is the galvanic cell. In that galvanic cell, okay, now what happens, you know, chemical energy is converting into the electrical energy. But coming to the third condition, there is a difference now. If you compare the first case and third case, there is a lot of difference here. Now here less than 1.1, but coming to the third one, it is the greater than 1.1. It means so at that time what happens here means at that time galvanic cell acts as electrolytic cell. Galvanic cell acts as electrolytic cell. Now what are electrolytic cells means already we know. Electrical energy is converting into the chemical energy. So that's why galvanic cell acts as electrolytic cell. Galvanic cell acts as electrolytic cell. When it is acting as electrolytic cell means whenever whatever the external potential that is applied, if it is greater than 1.1, at that time galvanic cell is acting as a electrolytic cell. Okay, right. Next, coming to the one more point. What is the point you have to remember here means coming to the here. Now zinc dissolves at zinc rod and copper deposited at a copper rod. So at that time, now in case if we consider these two things, okay. Now here zinc is acting as anode. Zinc is acting as anode here. And what about the copper means? Copper is acting as cathode. But coming to the third case, in this case, okay. Now here, so copper is acting as anode. And what about the zinc means? Zinc is acting as cathode. One more point you have to remember. So whatever you take, okay. Now here anode carries negative charge and cathode carries the positive charge. Here also anode carries the negative charge and cathode carries the positive charge. Now what is the point here you have to remember means if it is the electrochemical cell, if it is the electrochemical cell means in electrochemical cells always anode carries the negative sign and cathode carries the positive sign. Okay, right. So this is regarding the whenever we are applying the external opposite potential on the galvanic cell. Now here we are observing the three cases here. What are the means? These are the three cases. Okay, right. Next, coming to the next topic, what is the next topic means? That is galvanic cells. What is the next topic? Next topic is galvanic cells. Next topic is galvanic cell. In the last class we have discussed regarding the Daniel cell. Now in this class we are going to discuss regarding the galvanic cell. Now coming to this galvanic cell. What are galvanic cells means already we know. If we take these galvanic cells are the best examples for the electrochemical cells only. Now in that cells what happens? In galvanic cell what happens? Already we know. So chemical energy is converting into electrical energy. Chemical energy is converting into the electrical energy. Okay. Next point. Mostly such type of galvanic cells where we are using this galvanic cells means they are used for running motor. If you take that motors, so in that motors, so we observe the presence of which type of cells means they are galvanic cells only. Even they are also used in electric gadgets like fan, geyser, etc. Okay, so now these galvanic cells not only used in the running motors but also they are used in the electric gadgets like fan, geyser, etc. Okay, now so best example is already we have discussed now. Daniel cell is the best example. Now just to remember now, what is the difference between the Daniel cell and the galvanic cell means actually if you take a galvanic cell, now we are using the salt bridge here. We are using the salt bridge. But coming to this Daniel cell, okay, now here what we are doing means now this is the cell one measure we are taking. In that measure, now here, so this one is important now. So this is the porous spot or porous diaphragm. Okay, it means in the previous, it means if you take the galvanic cell, two measures we are taking, but coming to the Daniel cell, we are taking only one measure only. In that measure, now two half cells we are considering here, means zinc rod if you take that one, that is dipped in the zinc sulfate solution, and a copper rod is dipped in the copper sulfate solution. But now these two solutions are separated by a porous spot. Now porous spot or porous diaphragm. Okay, so if you use such type of porous spot, then such type of cell is called as Daniel cell. Okay, what is the difference between the galvanic cell and this Daniel cell means in Daniel cell we are not using any type of the salt bridge. In the place of that salt bridge, so mostly we are using a porous spot or porous diaphragm like this. Okay, now here right hand, here left hand side we are taking the zinc rod that is dipped in the zinc sulfate solution, and copper rod is dipped in the copper sulfate solution without using that salt bridge. Okay, by using this porous spot or porous diaphragm. Okay, now we are constructing the cell. Now that cell is called as Daniel cell. That is the main difference between the galvanic cell and the Daniel cell. Okay, right, let it be. Now coming to this galvanic cells here. Now if you take that galvanic cell, so mostly where we are using the galvanic cells, they are used for running motors, electric gadgets like fan, geyser, etc. Now coming to that one, and now already we know Daniel cell only I will take here also. Now if you take that Daniel cell, okay, in that Daniel cell what we are taking, zinc rod is placed in the zinc sulfate solution and a copper rod is placed in the copper sulfate solution here. At that time we observe the reduction reactions here. What are the reduction reactions means already we know. Now coming to the first one, I will write the first reaction here, that zinc. Okay, if you take that zinc one, now the zinc is converting into the Lead 2 plus by the loss of 2 electrons. And next coming to the second one, copper, that Cu2 plus 2 electrons here. Now it is converted to the Cu here. Here we observe the loss of electron, that's why it is called as oxidation. And here we observe the gain of electron, that's why it is called as reduction. And already we know. Now here zinc rod, now here it is acting as an anode. Why it is acting as an anode means because always oxidation occurs at anode. Next, reduction means now it is acting as a cathode. Okay, right. Next, coming to the next point. Now here in that galvanic cells, now we are taking the two vessels or two cells we are taking here. Now that cells, whatever the cells we are using in this reactions, now they are called as half cells. They are called as half cells, or they are also called as redox couples. Okay, whatever the cells that are used in this galvanic cells, the cells that are used in the galvanic cells, they are called as half cells or redox couples. They are called as redox couples. Okay, I'll write here. Next one, the cells portions, the cell portions which are used in the galvanic cells, they are called as half cells. Okay, or they are also called as redox couples. They are also called as redox couples. It means now here in case if we take that galvanic cell, in that galvanic cells we observe the presence of two half cells. Sir, you are telling that now in case if we take that galvanic cell, so there we observe the two half cells. Okay, now so what are the two half cells means? So I write here. Now in case if we consider this one, first one, now here Zn is converting to the Zn2 plus means loss of electron, that is known as oxidation. Now that entire cell, okay, now that entire cell, that is called as oxidation half cell. Oxidation half cell. Why it is called as oxidation half cell means because so if you take that zinc rod, now here zinc rod we have taken here. Okay, this is zinc rod. Zinc rod dipped in zinc sulfate solution, and copper rod is copper rod dipped in the copper sulfate solution. Now they are connected to the white side. Okay, now here what happens here? Now this zinc rod, whenever it is dipped or placed in the zinc sulfate solution, at that time we observe the oxidation. Now due to that reason only, now this cell, okay, this is called as oxidation half cell. This is called as oxidation half cell. Why it is called as oxidation half cell? Because here we observe the oxidation. So due to that reason only, now this vessel or cell, so now this is known as oxidation half cell. Okay, right. Next, coming to this one. Now in this case what happens now? In this case, in this half cell, so that Cu2 plus is converting to the Cu, nothing but gain of electrons. Gain of electrons means reduction. So that's why this one is called as, okay, this is called as reduction half cell. This is called as reduction half cell. Okay, now you understood now? Now here 2 points I told you. That is whatever the cell portions that are we have taken in the galvanic cell. Two cell portions are there now. Okay, now this is the first portion and this is the second portion. Now that cell portions are called as half cells. They are called as half cells, or they are also called as redox couples. Why they are called as redox couples? Because now in this galvanic cells, so we observe the redox reactions here. What are redox reactions? The reactions in which we observe both the oxidation and reduction. That's why these cell portions are also called as, they are called as half cells or redox couples. Now if you take the half cells, okay, now again they are classified into two types. What are the means? First one is oxidation half cell and the second one is reduction half cell. What is the difference between the oxidation half cell and reduction half cell means? Now if you consider the left hand side cell vessel, okay, in that cell we observe the oxidation. How we are telling that one? Now just once you see this reaction, Zn is converting to the Zn2 plus. It means loss of electrons. Loss of electrons is called as oxidation. Always oxidation takes place, means oxidation occurs at anode. Okay, right. Now that's why this is called as oxidation half cell and this one is called as reduction half cell. Okay, right. So this is regarding the next point. Next, coming to the third point. What is the third point means? Now here if we take this galvanic cell, it means now by using so Daniel cell, it means so Daniel cell or galvanic cell, whatever you take man. Now we can prepare a large number of or more number of such type of galvanic cell. We can prepare, okay, large number of or more number of such type of galvanic cell. How we can prepare such type of galvanic cells means by constructing, okay, two half cells here, that is like this. Different types of the electrodes you have to take here. Now they are placed in the different types of the electrolytic cell solutions here. Now they are connected, okay, by through a voltmeter, okay. So by connecting this one, now we can construct a different types of the galvanic cells here. Now what is the point you have to remember means if you take the Daniel cell, compulsory, so we have to take, mostly we have considering the zinc rod and copper rod. Now they are placed in the zinc sulfate solution and copper sulfate solution. Like that, we can also use different types of the electrodes here. Different types of the electrodes means like copper, means copper already we have used. Silver also we can use. Gold also we can use. Okay, even we can also sodium, magnesium, like that. So different types of the, by taking the different types of the metal electrodes, we can construct a large number of the galvanic cell. But the function and construction of the galvanic cell or the Daniel cell is same like this. Okay, two electrodes we have to take and they are placed in the electrolytic solution and they are connected through the metallic wire. Okay, construction and mechanism or functioning is same, but mostly what we are doing means we are using the different types of the electrodes. That is the only difference here. Like this, we can prepare a more number of or large number of different types of the galvanic cell. Next point. What is the next point here you have to remember means first one. Now see there. Now this zinc rod is placed in the zinc sulfate solution. And even here also, copper rod is placed in the copper sulfate solution. At that time, what happens here? Now we observe the interactions between this electrodes and electrolytic solutions. Okay, whenever we are placing these electrodes in these electrolytic solutions, okay, at that time we observe the interactions between the electrode and electrolytic solution. Okay, now I'll write that point. Whenever we are placing electrodes in the electrolytic solution, we observe interactions between electrode and electrolytic solution. Okay, whenever we are placing electrodes in electrolytic solution means so it may be the zinc sulfate solution or copper sulfate solution. Okay, at that time what happens? We observe the interactions between the electrode. This is the electrode, zinc electrode, this one, and this is the copper electrode. Now it is interacting with the electrolytic solution. Zinc is interacting with the zinc sulfate solution and the copper is interacting with the copper sulfate solution. What happens means at that time, okay, so whenever we observe the interactions between the electrode and electrolytic solution, at that time, now we are observing, so here you have to remember 2 points. Okay, whenever we are observing interactions between the electrode and electrolytic solution, at that time you have to remember 2 points. What are the means? First one, now in case we consider this one. Whenever this metal is placed in the electrolytic solution, at that time the metal ions enters into the ZnSO4 solution. Metal ions. That metal atoms are coming from where? This zinc rod only. Okay. Now they enters into the zinc sulfate solution or electrolytic solution, and here and leaving the electrons around the metal rod. Okay, so due to that reason only, now here what happens, negative negative charge is developed around the metal rod. Okay, right. This is the first case. Means so whenever we observe the interactions between the electron and electrolytic solution, at the time what happens in the first one, metal atoms enters into, okay, electrolytic solution. Okay, now that metal atoms enters into the electrolytic solution as metal ions. Okay, that metal atom means, this is the best example. Zinc rod is placed in the zinc sulfate solution. At that time what happens? That zinc enters into the zinc sulfate solution. Means Zn is converting to the Zn2 plus. Now that Zn2 plus ions enters into the zinc sulfate solution, leaving electron. Now here these electrons are there now leaving that electrons around this zinc rod. Okay, so due to that reason only, that negative charge is developed. Means negative potential is developed. Negative potential is developed around this zinc rod. Okay, right. This is the first point you have to remember whenever we observe the interactions between the electrode and the electrolytic solution. Next, coming to the second one. Here I have written. Now, next point is, now here, whatever the metal ions present in electrolytic solutions are going to deposit on the metal electrode. Okay, this is the second point you have to remember. So whenever we are observing interactions between the electron and electrolytic solutions, there are two possibilities. What are the two possibilities? Means first possibility, metal atoms enters into the electrolytic solution as metal ions, leaving electrons around the metal rod. So now here electrons are present around the metal rod. What about the charge of electron? Negative charge here. So due to that reason only, around this zinc rod, negative potential is developed. Okay, so that's why in electrochemical cells, anode always carries the which type of charge? Means negative charge. This is the first possibility whenever we observe interaction between the electrode and electrolytic solution. Next, coming to the second possibility. What is the second possibility? Means whatever the metal ions that are present in the electrolytic solution, they are going to deposit on the metal electrode. Best example is this one. Now see there, in copper sulfate we observe that now it is a electrolytic solution. Now it is undergoing the dissociation here. Due to that reason, Cu2 plus and SO4 2 minus ions are formed. Now these are the metal ions. They are present in this copper sulfate solution. Now these metal ions move towards the copper rod. Means they are moving towards the copper rod and they are going to deposit on the surface of the copper rod. Okay, it means what is the point I have written there? Metal ions present in the electrolytic solution. Best example is Cu2 plus ions present in the copper sulfate solution. Now they move towards the copper rod and they are deposited on the copper rod. That is the point I have written. Metal ions present in the electrolytic solution, they are going to deposit on the metal electrode. So due to that reason, what happens here now, that Cu2 plus ions are present around this metal electrode. That's why now here positive potential is developed here. So due to that reason only, okay, so why here we observe the development of the positive potential or positive charge? Now cathode carries the positive charge. What is the reason for that one? This is the reason. So now it is developing the positive potential around this metal rod. Okay, so that's why. So it is means in electrochemical cell, now this copper is acting as cathode and it is denoted by the positive sign. Now here zinc is acting as anode, and it is denoted by the negative sign. Okay, right. So this is regarding how to construct a Daniel cell or even that is galvanic cell here. But what is the difference between the galvanic cell and the Daniel cell means already we know. In Daniel cell we are not using the salt bridge. In the place of the salt bridge, so only we are taking a porous pot or the porous diaphragm we are taking. By taking that one only we are constructing the Daniel cell. But coming to the galvanic cell, mostly we are using the salt bridge. Okay, right. Let it be. Now in that galvanic cell, so here what are the points you have to remember means these are the points ma. I will repeat once again ma. That is galvanic cell. Galvanic cell. In galvanic cell what happens ma? Chemical energy is converting into the electrical energy. Mostly they are used for running motors. They are used for running motors, electric gadgets like fan and geyser, etc. Okay. Now in case you take that galvanic cell, in that galvanic cell we observe the redox reactions here. Okay, what are the redox reactions means? Now the functional mechanism of the galvanic cell means it is like this. Okay, now we are taking the two cells here. In that two cells we are placing the electrodes here. Now they are connected through the metallic wire here. Okay, next one here. What happens if we consider the Daniel cell, that is zinc rod placed in zinc sulfate and copper rod is placed in copper sulfate. At that time these are the two reactions we are observing. Oxidation is occurring here. Next one is the reduction. What is the point you have to remember? Always oxidation takes place at anode and reduction takes place at cathode. Okay. Next point. Now, if you take that cell portion, two cell portions, whatever we are taking in the galvanic cell, now they are known as or called as half cells, or they are also called as redox couples. Now, if you take that half cells, now they are classified into two types. What are the names? One is oxidation half cell and the second one is the reduction half cell. Now coming to this one, this is okay considered as oxidation half cell. Why it is considered as the oxidation half cell means because here we observe the oxidation. That's why this is the, so here we are observing the oxidation reaction. Now this cell is called as oxidation half cell. Now coming to the second one, now here we observe the reduction here, that is Cu2 plus is converting to the Cu. So that's why now here we observe the reduction. That's why it is called as reduction half cell. Next, third point is important for us. What is the third point? Now, whenever we are placing these electrodes in electrolytic solution, either ZnSO4 or copper sulfate. Okay, whenever that electrodes are placed in the electrolytic solution, at the time what happens? We observe the interactions between what and what means between electrodes and electrolytic solution. At that time there are two possibilities. What are the two possibilities? First possibility, metal atom enters into electrolytic solution. Metal atoms enters into electrolytic solutions as metal ions leaving electrons. It means best example is zinc rod is placed in the zinc sulfate solution. At that time what happens? Zn is converted to Zn2 plus. Now, whatever the Zn2 plus ions that are produced during the course of the reaction, now they enters into the ZnSO4 solution, leaving the electron. Now that electrons are present around this metal rod here, that is around the zinc rod here, it means now electrons are present around the electron, so that's why negative potential is developed. That's why anode is denoted by the negative sign. This is the first possibility. What is the first possibility? Metal atom enters into the electrolytic solution as metal ions. Next, second possibility. Metal ions present in the electrolytic solution. They are going to deposit on the metal electrode. Best example is this one. Now see this reaction. Cu2 plus is converting to Cu. Now that Cu2 plus ions are coming from where means copper sulfate solution. Metal ions present in the electrolytic solution. Now they are going to deposit on the copper rod. So that's why now this is the second possibility that is observed whenever we observe the interactions between the electrode and electrolytic solution. Okay, right. These are the points you have to remember whenever we are constructing the galvanic cell. It means so we can prepare too many means large number. We are writing like this, innumerable. Innumerable means so too many large number of galvanic cells can be prepared by constructing this one. Okay, right. So this is regarding the galvanic cell. In the next class we are going to discuss regarding the that is what is the meaning of electrode potential, cell potential and EMF. Okay, the next class will continue. Thank you. Tomorrow will continue.